Assalamualaikum and good morning everyone. Thank you for being here today. I'm delighted to have the opportunity to share with you how to determine the concentration of vitamin C in melon using direct titration technique.
Before that, I will explain a little bit about our technique that we use, which is direct titration. What is direct titration? Direct titration, also known as a direct titrometry, is a common analytical technique used to determine the concentration of a specific substance in a solution. Adding standard titrant directly to the analyte when an acid-base indicator is present, and the reaction is ongoing until it reaches the equivalent point. Next, to do this experiment, we must know the direct titration setup process. First of all, set up the burette, secure it to the stand and fill it with the titrant solution. Ensure there are no bubbles and record the initial volume. Second, prepare the analyte. Measure the analyte solution using a pipette and transfer it to the Erlenmeyer flask. Add a few drops of the chosen indicator. Number 3. Position of the flask. Place the Erlenmeyer flask under the burette on a white tile or paper to observe the color change clearly. Number 4. Begin titration. Gradually add the titrant from the burette to analyte solution while continuously stirring. Watch the endpoint indicated by the color change. Last but not least, record the volume. Note the final volume of titrant used on the endpoint is reached. Use this volume to calculate the concentration of the analyte.
Vitamin C, commonly known as ascorbic acid, is a water-soluble vitamin with a monosaccharide structure. Melon, Cucumis melon, is a fruit that belongs to the Cucurbitaceae family and has the potential to be developed through plant breeding. Many analytical techniques, such as T3 metric, are mentioned in the literature for determining the vitamin C in various matrices. In this study, vitamin C was determined by the direct titration method. Studies that systematically compare ascorbic acid contents of melons, especially the differences among varieties. The objective of the experiment is to determine the concentration of vitamin C in varieties melon by using direct titration technique in volumetric analysis. And this is the chemical equation for this titration.
Next, I will explain about the methodology. First methodology is preparation of samples. Fresh sample of two melon varieties, which is Rocket and Rock melon, were obtained. The samples were washed with water, then peeled and sliced into smaller portions. After that, the samples also were weighed, squeezed in a juicer machine and centrifuged. Then the volume and weight of the supernatant liquid were taken. Second methodology is standardization of sodium thiosulfate solution. This standardization was accomplished by pipetting 10 ml of 0.017 molar potassium iodide solution plus 10 ml of 10% potassium iodide solution plus 10 ml of 1 molar sulfuric acid into a conical flask. The liberated iodide was titrated against a burette solution of sodium thiosulfate until a faint yellow color was obtained. Then, 4 drops of 1% starch solution were added, and the titration was continued until the starch triiodide complex blue black color completely vanished. Third methodology, which is the last part of methodology, is determination of the concentration of ascorbic acid. For this part, 10 ml of the sample solution was pipetted into a conical flask, then followed by 2 ml of 1 molar sulfuric acid and 10 ml of 0.05 iodine solution. The generated excess iodine was titrated against a solution of 0.1 molar sodium thiosulfate. The titration method determines vitamin C in the form of ascorbic acid.
Next is the results of the titration. The average concentration of ascorbic acid was calculated from the 3 different volumes of the sodium thiosulfate. Based on the results, the concentration of ascorbic acid inside the skyrocket melon is 3.42 and for the rocket melon is 3.23. It was clear that the color of the fruit flesh affects the difference in the vitamin C content between two varieties of melon fruits. The flesh of the rock melon is orange, whereas the flesh of the skyrocket melon is greenish yellow. The average ascorbic acid content of the skyrocket melon is higher than the rock melon. Let's move on to the calculation. To calculate the concentration, the formula used is M1V1 divided by M2V2 equal to N1 over N2, where the M is for the concentration, V is for the volume, and N is for the moles. The M1V1 and N1 is stand for the ascorbic acid, and M2V2 and N2 is stand for the sodium thiosulfate. The concentration of each volume was calculated and the average concentration was taken. The average concentration of skyrocket melon is 3.42 molarity. The same goes for the rocket melon. The formula used is M1V1 divided by M2V2 equal to N1 over N2. The concentration of each volume was calculated and the average concentration was taken. The average concentration for the rocket melon is the 3.23 molarity.
In conclusion, there are differences in the ascorbic acid concentration of the two melon varieties. Flesh color affect the difference in the ascorbic acid content between two varieties of melon fruit. The result recorded the concentration of ascorbic acid in skyrocket melon were higher than rocket melon. Varieties with high ascorbic acid level may provide producer with a competitive marketing and supply niche. In this experiment, the concentration of vitamin C in melon was determined using a titration method involving a standard solution of sodium thiosulfate and a starch indicator. The objective is to quantify the amount of vitamin C present in a melon sample through a direct titration technique. 10 ml of melon juice was extracted and filtered to remove any seeds. The juice was then titrated with a standardized sodium thiosulfate solution. The endpoint of the titration was identified by a persistent color change. The volume of sodium thiosulfate solution required to reach the endpoint was recorded. By using the stoichiometry of the reaction between sodium thiosulfate and vitamin C, the concentration of vitamin C in melon was calculated. To reduce error in titration and improve the accuracy of our results, we should use high-quality equipment. Ensure that we use high-quality glassware, burettes, pipette, and other equipment. Calibrate our equipment regularly to ensure accuracy. Other than that, we should standardize all solutions used in the titration process to ensure the accuracy. This includes the titrant solution and any solution used for calibration. Lastly, maintain proper technique. Follow proper titration techniques such as slowly adding the titrant drop by drop near the end point, swirling the solution gently to mix, and ensuring proper reading of the meniscus.